finally, in section 1.7, we'll discuss equations that are what we call quadratic in form. An equation is quadratic-like or quadratic in form if it can be written in the form lowercase a times the capital A squared plus b times capital A plus c is equal to 0, where lowercase a, b, and c are constants, a is not equal to 0, and capital A is an algebraic expression. Such equations can be solved by first solving for capital A and then solving for the variable in the expression, capital A. This method of solution is called substitution. And like many things with math, this is going to make more sense when we look at an example. So let's start there. If we look at part A, we can see that it is quadratic in form because we know that a quadratic equation has the format of ax squared plus bx plus c is equal to 0. So quadratic in form means that you have a variable, in this case x, that is squared. In this case, the variable that is squared is x squared plus 2x. You then have a number times that same variable to the first power. So we have a number times that first variable to the first power. And then you have a c value that sits by itself without a variable, which we have as well. So the idea is that we're going to take this x squared plus 2x, which is playing the role of our variable, and replace it with a capital A. And so now our problem becomes capital A squared minus 7 times capital A minus 8 is equal to 0. Now, is this factorable? It looks now like a normal quadratic equation. Although typically we would have x's, we now have a's. Let's see if we can factor this. Remember that the number that you put here and here have to multiply together to give you a squared. So we're going to know that we need an a and an a. The numbers that go in the back two positions have to multiply together to give you 8, and they need to combine to give you 7. So our options for multiplying numbers to make 8, we can do 8 and 1, we can do 2 and 4. But 2 and 4 do not combine in any way to give you 7. So 8 and 1 are going to be, or is going to be, the better choice. So now what do your signs need to look like? We need a negative 7. So that means that on this 8, we need the negative, and on the 1, we need the positive. Now again, if factoring is something that you feel weak in, you would want to FOIL this out to be sure that you have it correct. And so then we'll set each of these equal to 0. So a minus 8 is equal to 0, and a plus 1 is equal to 0, and we'll solve for a. So on the first one, we'll add 8 to both sides. On the second one, we're going to subtract 1 from both sides. So we get a is equal to 8, and we get a is equal to negative 1. Now, once we have solved for the a, we're going to go back and substitute back in for our original variable. So remember that we let a equal x squared plus 2x. So we're now going to say, instead of saying a is equal to 8, we're going to say x squared plus 2x is equal to 8. And instead of saying a is equal to negative 1, we're going to say x squared plus 2x is equal to negative 1. And we're going to work at solving these two quadratic equations. Now we know to solve a quadratic equation, we need it set equal to 0. And so that's going to be our first step, is that we're going to subtract this 8 off of both sides of the first one, giving me x squared plus 2x minus 8 is equal to 0. On the second one, we're going to add 1 to both sides, giving me x squared plus 2x plus 1 is equal to 0. And the idea is that I should be able to factor those two right, so let's see if we can get that done. We know that we would need an x and an x. In order to multiply two numbers together to make 8, again, we can do 8 and 1 or 2 and 4, but this time we need them to combine to make 2. So 2 and 4 are the logical choices here. We need the middle term to be positive, so that means that we need the larger number to be positive and the smaller number to be negative. On our other problem, again, we're going to have x and x. To make 1, it's going to be 1 times 1. It's our only option. And they're all pluses, so there'll be pluses here as well. And so now we're going to set each of those equal to 0 and solve. And when you do that, you're going to come up with 3 solutions. You're going to come up with positive 2. You're going to come up with negative 4. And over here, you're going to come up with negative 1. And again, you can note that negative 1 is a double root and has a multiplicity of 2. Okay, so we're going to do the same sort of thing on part B of this problem. All right, so we are going to let A equal something that is squared on the first term, something raised to the first power on the second term. Okay, and so it's going to make sense to let this be the A. And so now I need to think about how to, or whether that would work for the first term. So if I had y to the 1/3 and I had it squared, is that the same thing as y to the 2/3? And we know that here we would multiply, so yes, 1/3 times 2 is 2/3. All right, so this is going to work out perfectly to let the A equal the y to the 1/3. So this is going to be the A, and then we'll have it squared. This will be the A raised to the first power, and then we have minus 5. All right, so let's look at what we've got. We've got A squared plus 4A minus 5 is equal to 0. Our goal is to try to factor that. It would have to be A and A. To make 5, it would have to be 5 and 1. We need a positive 4, so we need the larger number to be positive, the smaller number to be negative. We'll set each of those equal to 0. So A plus 5 is equal to 0, and we'll subtract the 5 off. So A is equal to negative 5. A minus 1 is equal to 0. We'll add 1 to both sides, so A is equal to 1. And again, once you have solved for A, then you need to go back and reverse the substitution and solve for x. So remember that, or y in this case actually, so remember that we substituted for A, y to the 1/3. So I'm going to say y to the 1/3 is equal to negative 5, and y to the 1/3 is equal to 1. And so how do we solve these two equations? They are not quadratic anymore. We just need to solve for y. So the easiest thing to do would be to raise both sides of this to the 3rd power. And in doing so, that's going to take care of your fractional exponent here. So 1/3 of 3 is just going to be 1. Negative 5 to the 3rd is going to be negative 125. And over here, we'll have y is equal to 1 to the 3rd is 1. And so we have now solved our quadratic-like equation, and we know that the solutions would be negative 125 and positive 1. Now, we're going to look next, or finally, at a section of equations that are not necessarily quadratic in form, but equations that do have a higher power than the 2, and will often have a quadratic part to them. So we're going to do 4 of these quickly. The first one is x to the fourth is equal to 9. So let's take this equation and let's first move the 9 to the other side, setting it equal to 0. Now, if you look at that, we can factor that using a difference of two squares. We know that x to the fourth could be written as x squared squared. And the 9 could be written as 3 squared. And so remember, a difference of two squares factors into x squared minus 3 and x squared plus 3. That is a special factoring property. And if we set each of those equal to 0, x squared minus 3 is equal to 0, x squared plus 3 is equal to 0, and we work at solving. On the first one, we would add 3 to both sides, giving me x squared is equal to 3, and then take the square root. So x is equal to positive or negative square root of 3. There are two solutions. For our second one, we'll subtract 3 from both sides. So we get x squared is equal to negative 3. We'll take the square root and we get x is equal to positive or negative. Remember, if you take the square root of a negative, it comes out as an I. And we cannot take the square root of the 3. And so we have 4 solutions to this quadratic equation, or to this equation. It does have a quadratic component because we're seeing those squared terms come into play. All right, so for part B, we have 4 terms. We know that for 4 terms that we typically will factor by grouping. So we're reviewing some of those factoring techniques. We typically will group the first 2 problems, the first 2 terms together and the last 2 terms together. Remember, you're looking for something that's common. So what is common between y squared and y to the third? We could pull out a y squared. So y squared, we have 2 on the outside. We need 1 more to make a y to the third. Y squared times what to make y squared? We need a 1. In my second set, I can see that I have a negative 4 that's common to both terms. So negative 4, taking that out of the first term leaves me a y. Taking a negative 4 out of the second term leaves me a positive 1. And so now we treat this as a term and this as a second term. And what's common to those 2 terms? They both have a y plus 1, so we're going to pull that to the front. When we pull a y plus 1 out of the first term, we're left with y squared. When we pull a y plus 1 out of the second term, we're left with negative 4. The y squared minus 4 is a difference of 2 squares, and so it will factor into y minus 2, y plus 2. And you can set each one equal to 0 and come up with solutions. Y is equal to negative 1, y is equal to 2, y is equal to negative 2. All right, part C, we have 8t to the third minus 27. Note that this is a difference of 2 cubes. And so we can write the 8t cubed as 2t to the third power. We can write the 27 as 3 to the third power. And so we have a formula. You might have to go back in your notes to look and see what that formula looks like. That tells you how to factor a difference of 2 cubes. Remember that that formula says to do the first one minus the second one. So we're going to do 2t minus 3. Then we'll do the first one squared. So 2t squared plus the 2 multiplied together. So 2t times 3 would be 6t. Plus the second one squared, so 3 squared is 9. And we'll clean that up just a little bit. So 2t squared is going to be 4t squared plus 6t plus 9. And this is going to be set equal to 0. We'll set each part of that equal to 0. 2t plus 3 is equal to 0. And 4t squared plus 6t plus 9 is equal to 0. Solving the first one is easy because we can subtract the 3 from both sides, giving me 2t is negative 3, and divide both sides by 2. T is equal to negative 3/2, and that's one of our two solutions. You know what? I made a small mistake there as I'm looking at it. I changed that subtraction there to a positive. Let's fix that. Sorry about that. All right, so it is a subtraction. So we would be adding 3 to both sides. All right, so our solution would be t is equal to 3/2. Now, for the other one, the 4t squared plus 6t plus 9, we know it's not going to factor because of the way that this worked out. So we're probably going to be left with doing quadratic formula. All right, so let's quickly plug that in and see if we can make that work. We're going to say negative b would be negative 6. B squared would be 6 squared minus 4 times the a times the c, all over 2 times the a. So we are going to have negative 6 plus or minus 36 minus 144 over 8. Which is going to be negative 6 plus or minus the square root of negative 108 over 8. So 108 we could write as 36 times 3. Alright, so let me find myself a little bit of space here. Alright, so we're going to come up here to the top. So negative 6 plus or minus. Alright, so the 36, I can take the square root of that. That's going to be 6. The negative is going to produce an I on the outside, and the 3 is going to stay underneath. And we're going to divide by 8. Remember, we can simplify if we're simplifying those 3 positions. So they are all 3 divisible by 2. 2 goes into 8 4 times. 2 goes into 6 3 times. And so our final answers here would be t is equal to negative 3 plus or minus 3i on the square root of 3 over 4. So we have 2 solutions coming out of that one. We also have the 3/2 solution at the bottom. So 3 solutions to the original equation. All right, and finally our last example, we have 3x to the 4th plus 18x to the 3rd minus 21x squared. So looking at that, what is common to all 3 terms, we would want to pull that to the front to begin with. As far as the numbers go, we can pull out a 3. As far as the x's go, we can pull out an x squared. So 3x squared times x squared to make 3x to the 4th. 3x squared times 6x to make 18x cubed. And 3x squared times a negative 7 to make negative 21x squared. So let's check and see if what's in parentheses is going to factor. It would have to be x times x. It would have to be 7 times 1. We want a positive 6x, so our larger term would be plus and our smaller one would be minus. We'll set each of these equal to 0. So 3x squared is equal to 0, x plus 7 is equal to 0, and x minus 1 is equal to 0, and we'll solve. And so we'll have a solution of 0, negative 7, and positive 1.